Hello, and welcome to Beyond the Gates. I'm Annette Kirkland, and this season we're going to be talking about 7 labs, 1 ERDC. Discover the power of ERDC's 7 laboratories as they bring their technical expertise together to solve the nation's toughest challenges, from developing technologies that support the warfighter to improving the civil work systems we rely on each day. See how each of these 7 labs play a unique role in engineering a safer, better world. This morning I have with me 2 people, I say people, with the Geotechnical and Structures Laboratory, otherwise known as GSL. I have with me Anna Jordan. She's the Acting Technical Director, Force Protection, Weapons Effects, and Justin Strickler. He's the Lead Technical Director, Military Engineering, Force Protection Maneuver. Good morning.
Good morning.
How are y'all this morning?
Doing well. Good to be
Great.
here.
Thank you for having us.
Absolutely. We're super excited because both of you guys have never been on the show, first of all. So
That's correct.
I had to do a lot of arm pulling, right? Let's come on.
Twisting, yeah.
Twisting,
Yeah,
pulling,
yeah.
whatever you want
dragged
to
us
call
in the door.
I know, I did. I had to make sure that they they could come talk about the amazing things that GSL does. So we're going to start off with my favorite question. I don't know if it's your favorite question, but it's my favorite question. Could you tell me both about yourselves, your background, and your roles at GSL?
Yeah, sure. Always happy to talk about myself. It's one of the things I'm good at. My name is Justin Strickler. I'm actually from Mississippi, grew up down on the Mississippi Gulf Coast. And I have kind of an unusual route to ERDC compared to most of our researchers. After I graduated from high school, I went to the Naval Academy, and then I joined the Marine Corps. And I did a few years in the Marine Corps. And when I was getting out of the Marine Corps, I was searching for my next great opportunity and happened to find ERDC. And so I was hired in as an associate technical director into our military engineering program, trying to help manage that portfolio and run that portfolio. And then from there, I went to be a division chief in GSL, and now I'm the technical director for military engineering. So unlike most of the people, I don't have a super technical background of doing research. I have an ocean engineering degree, which is a little bit out of place at GSL. I think I'm maybe...
It sounds fun.
Yeah.
That sounds fun.
Yeah, well, I started out at CHL, and so it fit well there, but moving over to GSL. But luckily, they didn't hire me for my engineering ability. They hired me to manage things, which I'm a little bit better suited for. So, yeah, it's a little bit about me and how I got here.
Okay, great. Anna?
Hi, so I'm Anna Jordan, and unlike Justin, I grew up in Vicksburg. My father worked at ERDC. I grew up being there as a child, and so I went to Mississippi State and got my bachelor and master's degree from Mississippi State. Go Dogs! And currently I'm the acting technical director for survivability and protective structures here in GSL. But I actually started at ERDC as a student straight out of high school, and then never looked back. I'm still here 20 years later. Maybe I'm aging myself there, but I really grew up in GSL in the structural and engineering branch. And so I started there straight out of high school and spent probably 13 to 15 years in that branch, going from a student where I was, studying mechanical engineering, learning how the engineering things work at ERDC, and basing my classwork and things off of that, to eventually taking on leadership roles where I was actually a deputy program manager within the military direct research program. And then I eventually moved into more of a management role, actually working under Justin for a little while. He was the division chief, where I was the branch chief in the airfield and pavements branch. And there I was able to direct a really large team and healthy research portfolio. And so as I moved into those more management roles, I really realized that, I do like the technical engineering side of things, but my true passion was really in helping others find their way and find their purpose, and understanding the bigger picture as a whole that we at ERDC have. And so that's kind of how I got here.
Plus, it's in your blood. I can tell.
It's in my blood.
Well, great. So, for our listeners who might not be familiar with your lab, how would you describe the overall mission of GSL?
That's a great question. And so, from my perspective, GSL's mission is to conduct world-class research, right, and development in the geotechnical and structure engineering realm. And so we deliver these high-impact solutions, and our ultimate goal as a lab is to support the readiness of the DoW and the resilience of the nation across both military and civilian applications. And so essentially, the work that we do involves basically the ground we build on, the structures we rely on, the materials. How do we use these unique materials to build different things? And our lab is leading that charge today. And so honestly, it's really a dual mission that serves two critical customers, right? We have, on one hand, we have our civil works mission, where we focus on our national infrastructure. We're applying our expertise to enhance the resilience of our nation's dams, levees, waterways, trying to make them safer and more durable for future generations. And then on the other hand, we have our military mission, which is one of our really core roles in our lab. So on the military side, we're actually designated as the tri-service lead laboratory in two massive areas, and those are the airfields and pavements and the survivability and protective structures. And so what does that mean? Our lab is responsible for ensuring that our nation's military power projection platforms are viable to our nation. And we study exactly how these structures respond to weapons effects, enhance survivability of our forces. And so while we're doing that, we're simultaneously developing and advancing these pavements and rapid repair technologies that ensure we can maneuver and deploy anywhere in the world.
So important. So important.
Very important.
So, Justin, do you have something to add?
Yeah, I'll just talk a little bit about some of the facilities that we have that enable us to do all that research that Anna just mentioned, right? So USACE is, kind of the civil engineers for the nation, both on the military side and the civil work side. And so, we are kind of the civil engineering research lab, that makes all that possible. In order to do that research, we have to have some of the most unique, one-of-a-kind facilities anywhere in the world, right? So, most people wouldn't know, but we have a very large centrifuge on station, right? And that allows us to scale gravity and look at things in a scaled down version, which is more cost effective than going out and do a full field test. We have the world's biggest heavy vehicle simulator, so we can put 20 years worth of traffic over an airfield or a pavement without having to go out and wait 20 years to do it. And so all of these facilities we have that allow us to scale things, right? We have researchers doing things at the bench scale in the lab, and then you go out and do rapid big field tests. And then we also leverage some of our high performance computational modeling to be able to really deliver a full scale solution, right? And that's one of the most unique things about what GSL does. We can do everything from lab scale to full scale, couple that with our computational modeling to really deliver the best solution we can for the nation.
So that being said, with the theme of our show this season is discovering the power of ERDC 7 labs united to solve challenges. Can you provide an example of how GSL has partnered with another ERDC laboratory to tackle a challenge that neither could have solved alone? Yeah,
great question. And I'll try to give you an example that really highlights the collaborative nature of what we do. Anna and I are GSL employees, but as we represent the military engineering research and development area, which really cross-cuts across all 7 labs. And what we find is, when people come to us with problems or challenges, right, the reason they're coming to us is because they're complex and nobody else has been able to solve them. So one example I'll talk about briefly is we had a product called SubMat, right, which is a submersible, that's a tough word, matting solution that we actually developed for U.S. Transcom, right? So they came to us with a problem conducting mobility, vehicle movement across littoral zones, so beaches, soft soils, is a challenge, especially when you have a heavy vehicle, right? Imagine moving a tank across a swamp. It's just going to sink in. And so, ERDC has 7 great laboratories. GSL has really good knowledge of soils. We also have really good knowledge of structures, right? And we couple that with our coastal and hydraulics lab, who understood the surf dynamics, the hydrodynamic problem set in the littoral environment. And by bringing those two skill sets together, right, we were able to provide a solution back to Transcom and really ultimately to the soldiers to provide them a rapidly fillable cushion, for lack of a better term, that they can in place, within a few hours to provide that cross-shore mobility, right? To build up the combat power that the U.S. Army, the U.S. military needs to fight a fight, right? It takes a massive amount of logistics. And so, by bringing the two labs together, some of the most brilliant scientists and engineers, we could find to tackle this problem, we were able to deliver a really great solution.
Perfect. Anna, do you have anything to add?
Yeah, so I think that's a really, really great example of where we've had multi-lab collaboration. And as he mentioned, it was mainly on beaches. I would love to be able to just do field work on beaches. But, as ERDC, we have to be able to do a lot of projects all over the world in different environments. And so another example takes us to the exact extreme opposite, the Arctic, right? And so as the military focuses on more power projection in these colder regions and how do we build and maintain airfields in these environments has become a massive priority. And so at GSL, we're able to bring those expertise in advanced pavement technologies and the soil mechanics. And we know exactly how to design a runway that can take a heavy load of heavy military traffic or fighter jets. But the Arctic, it presents an entirely different challenge that at GSL we don't necessarily have those expertise in. Because the ground beneath that runway is completely unpredictable compared to some of the different soil mechanics that we normally study, right? And so we partnered closely with our Cold Regions Research and Engineering Laboratory, CREL, and they have those expertise. They have that deep, specialized understanding of permafrost and ice physics and how these extreme freeze-thaw cycles happen. And so we can't just go to the Arctic and put down this standard heavy-duty runway, right? The heat and the pressure would just cause it to be destroyed.
Right.
And so being able to combine CREL's, thermal modeling with our GSL structural and pavement models, we were able to engineer airfields that can survive in these extreme freeze-thaw cycles. And neither lab could be successful at being able to deliver those capabilities alone because our expertise aren't, we don't have those in each lab. They're as a joint force, though, we're able to provide those solutions.
Awesome. So, together, teamwork makes the dream work.
Absolutely.
That's right.
Right. So a key pillar of ERDC's mission is military engineering. So GSL is the lead for protecting everything from a foxhole to a fixed facility. Can you tell us a little more about that and what does that actually look like, especially when defending our troops against new threats like drones?
Yeah, so Ned, I'm gonna take this question,
Okay.
Especially with my current role as the acting TD for protection. So actually, recently, Justin and I had the opportunity to attend the Protection Senior Leader Forum at Fort Leonard Wood. And while we were there, Major General Beck, who is the commanding general of the Maneuver Support Center of Excellence, MISCO, said something that really resonated with our mission here at GSL. And I'm paraphrasing kind of what he said, but he emphasized that protection isn't just an afterthought. It's a critical component of everything that the Army does, right? So we can maneuver to protect, we protect to maneuver, we protect to fire, we fire to protect. But he summed it up with a statement that really hit home. You can maneuver, fire, and sustain all you want, but you're only going to do it once if you don't protect. And he made it really clear that engineers are the primary protection asset, right? And if you think about it, engineers are the one who actively shape the battlefield before the enemy ever fires a shot, right?
Right.
You're, by digging fighting positions, erecting these overhead covers, or hardening a command post, our combat engineers are dictating how the enemy can attack. And so the dirt moved and the concrete poured by engineers truly is the first line of defense to make sure that our forces can fight another day and survive. And so looking at that philosophy is really a core mission that we do at GSL. So like when you mentioned the phrase from a foxhole to a fixed facility, it really means our engineering and science have to scale to wherever the warfighter is deployed to develop these rapidly critical or deployed to provide those critical assets, right? And so one extreme, you can think of a soldier that's out at the tactical edge. He needs this lightweight, modular, rapidly deployable protection that he can set up in minutes under fire. But then on the other hand, you need a permanent solution, right, for a strategic base that requires this massive hardened facility or infrastructure with highly advanced concrete steel designs to withstand those direct missile attacks. And so our engineers here at ERDC and GSL are having to engineer solutions for that entire spectrum. So how do you rapidly deploy and how do you withstand these permanent bases when it comes to these direct missile strikes? And so now the challenge is that the battlefield today is evolving more rapidly than ever before, right? So in the past, we used to worry about these linear threats. So, we had these munitions coming from the ground or straight ahead, but you would think building this thicker wall would make you feel more relatively safe, right? But now with the rise of these new threats like weaponized drones, the entire geometry of how we're defending has completely changed, right? Mm-hmm. And so the threat now is vertical. It's cheap. Adversaries are able to produce these quickly, and they're everywhere, right? Because they're cheap and quick to produce. And so to be able to counter that 360-degree threat, our team in GSL is having to constantly innovate for these threats. And so, we're not seeing this from only a lab level. We're seeing this, currently in the fight that we're fighting through Epic Fury, right? Right. And so our team in GSL is in direct support of that. And so fielding RFIs almost daily to be able to get these engineered solutions straight to the troops on the ground. And so I think we couldn't have these advanced technologies without our incredible team of researchers that are being able to adapt to these real threats in real time.
So important. Justin, do you have anything to add?
Nope, Anna covered them pretty good. Good job.
She got it done.
I'll let her have that win.
If you're just tuning
one.
So, beyond protection, a huge part of your job is making sure our troops can actually get to where they need to go. How do GSL's innovations keep our military moving? Like airfields from World War II.
Yeah.
Is an example. I mean, how far back?
Yeah, so it's really hard to talk about where we are today without doing a little bit of historical perspective and understanding where we came from. So, ERDC, right, we have our background of the Waterways Experiment Station, and next year I think we'll be celebrating our 100th anniversary of being located here on the bluffs of Vicksburg. And over time, the mission of Waterways, now ERDC, has changed. And in World War II, we really saw a need for airfields and pavements research to support the ongoing war effort, right? We were building bigger planes, B-29s, B-27s. Mm-hmm. We were building faster fighter jets, Mustangs, and so conventional technologies at the time couldn't support the needs of the military. And so from that need arose our airfields and pavements branch, which Anna is the branch chief of. And it's something we still maintain as a core competency for the Triad service. And so, starting in World War II, we did some research to figure out how we support efforts in the European theater. And then obviously we moved into the Pacific theater. And, as we were talking earlier about littoral movement in the littoral zone, right? And most of the islands that we went to had airstrips that we were made out of sand, right? And so we developed the pier steel plank to be able to put down on the ground to provide that hard landing surface. And we deployed that all over the world. And so today we still build on that legacy, right? We're still looking at matting solutions that can be used for airfield mobility, aircraft mobility, for surface vessels and surface vehicles, and then we've also expanded that into other areas, right? One of the strengths of the U.S. military is our ability to push logistics anywhere in the world, right? Somebody had a quote one time about amateurs talk tactics, professionals talk logistics, right? Because it takes a lot of logistics to keep a force supplied, and so being able to make sure that you have the ability to project your forces and the logistics sustainment tail that goes along with them to keep them in the fight is important. So regardless of really what environment, we have a history in airfields and pavements, but, we have the Coastal and Hydraulics Lab, which has a deep understanding of the littoral coastal environment. And so by bringing all of those aspects together, like Anna talked about earlier, we no matter where our forces are deployed, we have to be able to sustain them. And so we're doing research in force projection related to Indo-PACOM, related to the Arctic. All of these are really important. And one of the things that we, in addition to just supporting the Army, is the joint force, right? And so regardless of who has a requirement, we are the place that people turn to for their force projection technology. So we support the Marine Corps, we support the Navy, we support the Air Force, we support the Army. So understanding that, yes, we're an Army lab, right? We solve all of these problems for the nation in the force projection realm.
So many partners.
Absolutely.
So many partners. Anna, do you have anything to add?
I'm going to let the score tie up.
You gonna
that one adjusting.
All right. So the cool thing about ERDC, but it's not just about defense. GSL also works on the offensive. How do you help commanders quickly calculate exactly what happens when their weapons hit a target?
Yeah, so how I talked earlier, a huge part of our mission is protection. But you can't really have effective defense without having a deep understanding of the offense, right? It's truly two sides of the same coin. Because we're the ones engineering the concrete, the steel, the soil systems to survive these massive blasts, we know exactly where the failures are, right? And how do you defeat them? And so if you know how to build a bunker, you're going to know how to break it.
Right.
And, so one of the programs that we focus on within GSL is called the Terminal Weapons Effects, which is a technical way of asking what happens in those first few milliseconds at the exact moment a weapon hits the target. It's not just about the explosion, it's about the pure physics of how it impacts. How does that kinetic energy transfer from the weapons to the structure? How does that shock wave propagate through different materials? And, how exactly does that structure fail? Does it spall? Is it shattered? Is it being completely breached? And so to be able to really answer those questions, we don't just rely on computer models, right? We can do the models all day long, but we have to validate them. And so we do that by going out to the range and conducting these massive instrumented real-world tests. And so we actually literally blow things up, right? And then we use high-speed cameras and advanced sensors to be able to capture that data on exactly how these structures and materials are failing under this extreme pressure. And so this process really establishes the ground truth criteria that our teams are able to take back to be able to enhance our research, right? And so as our adversaries are building harder and deeper facilities, the data that we're collecting through these real-world testing events, we're able to take that and rapidly quantify the lethality and penetration depth of these next-generation weapons against our critical targets. And so this ensures our forces are able to maintain this superior weaponeering and battlefield dominance, and are actually able to use the right tools for the job that they're needing to get done.
Yeah, and one of the reasons that's important is, right, so like when you're on the battlefield and you're trying to figure out how to neutralize a target, generally we do the old adage of whatever it takes plus P, and that P means plenty, right? So if, but in the world where we're in right now, right, where we're talking about magazine depth and how many munitions we have, right, and how many can we expend, especially in a near peer large scale combat scenario, right? The option of adding P may not be there because you don't have the magazine depth you need to engage the amount of targets that may come open.
Right.
And so really understanding, right, like I need to put 2 weapons against this target or 3, right? So that you have enough available in your inventory to neutralize all the target sets that are going to come across. That's really important, right? And so our researchers every day, I mean, we have some of the best scientists and engineers and technicians going out there doing that work. And without them understanding, right, the physics behind all of these things, right? An explosion is a very dynamic event, right? Things happen in milliseconds, right? And understanding it at that really fundamental foundational level is absolutely critical to making sure that the commander, who has no idea how that weapon actually functions, is delivering the right effect at the right time to achieve an end state.
Everything is so data-driven.
Absolutely.
So, just like you said, GSL is known for blowing up things, right? In fact, I think people around here think that's all you guys do.
Make things go boom.
That's right. To study how they break, right? We've talked about that. But with the technology we have today, that real-world physical testing can be combined with supercomputers to give us an incredible understanding. So how does that information help you design structures that can survive the latest threats?
Okay, so I'll take this one. Yeah. So, I was thinking back. I was like,
I didn't know if you were going to short straw or something like that.
We were playing paper rock scissors here in the corner.
We lost.
Yeah. No, I was thinking back to earlier when you asked about collaboration with other labs, and I was like, yeah, I don't know why I didn't talk about ITL in one of those, because our information technology lab and our supercomputers are we leverage them for almost every single project we do.
Right.
We were talking about going out and doing full scale tests, and those are important, right? We have to go out and do those, right? We do not want to validate, or we don't want to say a solution is validated without going out and proving that, right? But that's costly. It takes time. As Anna mentioned earlier, right, we're answering RFIs in real time now for warfighters deployed in Epic Fury, right? And so we don't have the luxury to go out and do that. But what we do gather, the data we gather from those events, allow us to bring that back into the lab and leverage the expertise of our subject matter experts, who have in many cases developed these codes themselves, right? They have developed these.
The best people.
Right, yeah. It's amazing to me. I don't know anything about ones and zeros, and every time they start telling me what they did, I'm just amazed, right?
Right.
And so, these scientists and engineers are sitting at their desk, every day plugging away, making sure that we're developing the necessary computational tools to help us inform the physical testing and the solutions we're pushing out the door. And a big part of that is making sure that we can run those on the supercomputer, right? And the capability that ITL brings to the fight in terms of being able to do these massive math problems, right, is incredible to making sure that we have the information necessary and the analytical tools necessary to respond in a timely manner.
Great. And an episode that we'll have later on in the season, we're going to be talking to ITL, and they're going to talk about the supercomputer and kind of give you an analogy of how fast those supercomputers are, and so how important they are. So transitioning, we're going to transition to civil works. So GSL plays a vital role in maintaining and upgrading the nation's infrastructure. Could you highlight a recent civil works project where GSL's research directly improved the safety and longevity of important infrastructure in our nation?
Yeah, good question. And so Anna and I primarily focus on military research, but the sister component of that is our civil works mission set. And we absolutely want to be responsive to what the nation needs. And so, over the life of our lab, we've been called in to look at some really tough civil works problems. A lot of it is related to aging infrastructure, right? And trying to make sure that when these structures were built, whether it's a levee or a dam or a bridge, whatever, when they were built, 50, 75 years ago, the engineers at the time did the best they could with the technology they had. And they probably didn't anticipate the future we now live in, right? Where, in terms of a bridge, right, the loads that we see, the 18-wheelers, just the mass and the volume that we ask these structures to do is incredible. And those engineers back in the day were, incredible at what they did. But one of the more specific examples I can think of is the Sioux Lock and Dam up in the Detroit area. So the locks are very complicated, and if you've never seen one in operation, it's almost a sight to behold. But so the lock had basically a lever arm that opened and closed the lock to allow ship traffic to pass. And some people don't realize just how much commerce passes through our nation's waterways. I mean, it's one of the most critical, vital thoroughfares from an economic standpoint. So making sure that this lock was operational was really important. So the part that broke, it was a cast part from the mid 1940s. And finding a replacement part for that, they just don't have them on the shelf, right? You're not going down to Home Depot and finding that. And so, these are massive components, and using traditional methods, it would have taken about 18 to 24 months to be able to produce that replacement part. And so using some of our advanced additive manufacturing technologies, GSL was able to provide the specific material properties for the type of material they needed. And then we partnered with an industry partner to be able to produce this using WAM, and I don't remember what WAM stands for. It's additive manufacturing, wire arc additive manufacturing, something like that. But it's a really cool technology. It's 3D printing a metal structure. And so, working with the district there, our engineers here, and an industry partner, we were able to produce that part in about a 13-week time frame.
I was just going to ask, what was the time frame? Okay.
Yeah, so shrinking that down, right, from 24 months to 13 weeks.
Wow.
That's pretty impressive for what we were able to do.
Awesome. Do you have anything to add, Anna?
Yeah, I mean, I think this goes back to our world-class facilities and our expertise that we are able to leverage across all the different labs, right? Being able to have people that are forward-thinking and innovating for the future when it comes to, problems that affect our country, right? And so having those people be able to step in and fix a problem within 13 weeks when in reality it should have taken 2 years, really advances the future of how we're able to help fix aging infrastructure.
Okay. So how does the concept of resiliency mean in your laboratory, and how important is it to the research you conduct?
Yeah, so I think resiliency really is a foundation of our research, but it's also a word that can get thrown around a lot in engineering. But for me and how I understand it means something that's very specific, right? It's the seamless combination of survivability and rapid recovery. So people often think resiliency just means building things thicker, heavier, or more rigid to be able to withstand a hit. But from our extensive blast testing of our structural analysis that we do here in GSL, and that we know that our adversaries and even, hurricanes and Mother Nature, they're always going to be able to find ways to break things. And so you can't just pour endless amounts of concrete everywhere, right? That's an easy solution, but it's too slow and too expensive. And then we just have a concrete world, right? Not really what we want. So being able to have that true resiliency as being able to anticipate that a failure point's going to happen.
Right.
But how do you actively engineer a way past it? And so one example I thought of was, if a military airfield becomes completely unusable because of massive craters from a drone strike or a missile attack, which is, a pretty big conversation right now with everything going on. How do we use a strategy that isn't just crossing our fingers and hoping that this concrete's unbreakable, right? So being able to have that resiliency and having the advanced technology of things such as a lightweight structural matting or rapid setting concrete repair material that's already fielded in theater and in the hands of the troops. How are we able to give our combat engineers, this capability that they need to be able to assess the damage quickly, repair those deep craters quickly, and be able to safely land these aircrafts again in a matter of hours and not days or weeks. And so making sure that our resiliency is that no matter the threat, that our mission never stops.
Yeah, and I'll just add to that real quickly. I mean, the other aspect or another aspect is being able to bounce back faster and stronger than what you were before, right? And so if we do suffer, some type of kinetic event or Mother Nature strike, right? How do we recover from that as quickly as possible, right? And not only do we recover, but how do we, during that recovery process, make whatever we're recovering better, right? Make it more resilient for the needs of the warfighter of the nation, right? And so, our researchers are constantly doing research on, new higher performance concrete, right? So when we have the opportunity to go in and repair a lock or a dam, right, that what we're putting back there is not only as good, but it's better than what was there before, right? So we're taking that 50, 70-year lifetime and extending that another 100, 150 years, right? And the same thing is on the military side, right? If an airfield goes down, how quickly can we get that airfield back up, right? And give warfighters an opportunity to get back in the fight. And so everything we do, we have an eye towards making that asset or that technology as resilient as possible.
So important. So GSL is also known for its world-class testing facilities, like we've talked about in this interview today. So like the ABLS and heavy vehicle simulator that we talked about, we've referenced, how important are these unique facilities when it comes to solving the nation's toughest challenges? And I really think that we've really already talked about this. So if you want to dive into this.
Yeah, I think obviously, like you said, We've mentioned our world-class facilities almost in every answer that we've given so far, because I don't think it's an exaggeration. We could not solve the nation's toughest engineering problems without them.
Right.
And so I can talk directly to the HVS. It's an absolute massive piece of machinery. It's huge, and it's the largest in the world. And so we're able to use this HVS to program, to run aircraft tires, railroad, truck tires, and we can do this thousands of passes back and forth over a new runway design, and it runs 23 hours a day. We can run it all night long, right? And so by being able to do that in just a few short months, we can compress this 20 years of real world wear and tear on this new design or new pavement process material that we've engineered in a lab, and see how do these environmental stresses on this new pavement mix affect over 20 years.
Right.
And so being able to have that time compression capability is absolutely key to our success, right? The warfighter doesn't have 2 decades to wait for us to prove that, this new material will work on a new runway, and, it'll actually work in the field. And so being able to leverage the capabilities of the HVS allows us to push these new materials to their breaking point in a highly controlled environment, right? Like everything we do is instrumented. So we have that physical data and are able to validate it for our criteria models that where we can take that data and that information and confidently tell the Air Force or the Army or the Navy or the Marines that, hey, this new runway is going to perform exactly how we expect it to under your loads, right? And so being able to deploy these multi-million-dollar aircrafts, they're relying on us to make sure that the runways and the airfields work, right? And so that gives them mission success and confidence that things aren't going to go wrong.
I add to that real quickly.
Okay.
So we talked a lot earlier about blast weapons effects, and those are very dynamic events, and they're very complex. And so we have a lot of facilities that allow us to look at that very complex problem set in its individual eaches, right? So we have Kolsky bars, which most people don't even know what a Kolsky bar is, right? But allows us to understand really high strain rates, right? And then you mentioned the ABLS, and that ABLS allows us to understand these massive impulse shock loads that come from a weapon, but without the fireball, right? And so you can see through that. And that's the things that those are the facilities that we have, right? Whether it's our massive gas guns, our high velocity guns, the ABLS, our Kolsky bars, it allows us to break that really dynamic problem down and understand how each individual part of that problem set affects the overall impact of that weapon system.
Okay. So if you can believe this, we're to the last question. It's gone by so fast, and we've learned so much.
No time.
So I just want to start off by saying, before we get on to the last question, I just want to thank you guys for what you do for the nation. It's so important. And I think, like I said, that people listening today, I think they learn more and more about what ERDC does, what this, you guys are GSL, but again, you work with all the labs, and it's super important that 7 labs, 1 ERDC, and that's what we're stressing this season. So thank you guys for what you do. Appreciate it.
Appreciate it.
So looking ahead in your crystal balls that you all have, that we all have, can you share any final takeaways you want our listeners to understand about the importance of the work being done at GSL?
Yeah, so good question. And I think a lot of the work we do kind of happens behind the scenes. Most people probably don't know about it, right? And so, what I would really like, for people listening today to understand is we may not be visible everywhere, but we're absolutely critical to making sure that things are happening to keep the country running, right? Whether that's making sure our waterways and our land dams and levees are operational, or whether that's protecting the warfighter overseas. We touch a lot of parts of people's daily lives. And the work we do absolutely adds value in every aspect.
Okay. Anna?
Yeah, I completely agree. And, I'll just add that this incredible impact wouldn't be possible without the people, right? And we've mentioned the people a few times that, they truly are what makes ERDC, right? It takes an entire dedicated team to be able to successfully solve the nation's toughest problems. And you have to have all of those pieces working together. And it starts with, our dedicated support staff, our incredible technicians that help us do the field testing and the field work, our administrative professionals that help us stay paid and get to where we need to be for travel. And, it's our massive complex, they keep our massive complex labs running safely and efficiently. Those people are the foundation, but then you have our entry level engineers and scientists who have this incredible energy and new perspective that they bring right out of college, right? But being able to mentor them with our senior researchers who have these decades of experience that are able to provide this knowledge to our younger engineers. But then you have our leaders who have to set the strategic vision to ensure that our research is always focused on the right challenges and the right mission sets, right? And so making sure that you realize every single person matters at ERDC to make our team successful And I think that at GSL is one of the cultures that we really have, is making sure that collaboration and mentorship is done, because that's one of our most powerful assets that we have as a lab. And so, the work that we're doing ultimately is helping to save soldiers' lives, right, and secure our great nation. And it takes every single one of us to be able to do that, to fulfill that critical mission.
That's a great way to end the show. Thank you.
Thank you.
All right. Again, thank you, Anna. Thank you, Justin. I appreciate you guys being here. And thank you for listening. And this is Beyond the Gates, and we'll come back at you next week. Have a great day.